Hello and welcome back to Introduction to Nanoscience and Technology. My name is Mike Ascuti and I'd like to focus in this lecture on Max Planck's key contributions that laid the groundwork for quantum physics, which is the more accurate description, especially of the nanoscale, that began roughly 100 years ago. So let's start with our notes. And Max Planck, or Planck, his key contribution really was this proposal, this hypothesis that the energy an atom can have must be, first of all, discrete or quantized. Oh man, I'm misspelling things everywhere. It must be quantized. Or another way of saying that is discrete. And so it can't take any value, but it has to take a specific value. And this set of specific values can be given a number. And this number is sometimes called the quantum number. And usually it's called n. All right, so this quantum number describes the state, if you will, of the atom and its particular energy that it might be talking about. Now, this energy of an atom must also be proportional to frequency. And this is the frequency of oscillation of the atom, or if this is more generally applied, then this could be the frequency, for example, of the photon. All right, now, also he said this should be proportional to a constant. And this constant he called just h. And he called it after himself. And this h, let me use a different color here, this h has a value of 6.629. Wow, I've never made so many mistakes on a single page. So hopefully you can do better than I. And it's 6.629 to the power of minus 34 joules seconds. And that power, 10 to the minus 34, is really important because it's a very, very small number. And what this means is that if Max Planck was correct in his hypothesis, then it means two things. One, at classical energy values, those values of kinetic and potential energy that we experience for baseballs and particles and heat and energy that we experience at our scale, these classical energy values, and because of this constant, then the quantum number are huge. So the relevant quantum number is not 1, 2, 3, or 4, but rather it's millions and millions, or even much more. And so that matters actually, because then some of the quantum effects that we'll talk about in the coming lectures, we're not going to see them very much, if at all, at this larger scale. All right, but at the nanoscale, so for objects and effects that occur on small scale, nanometer scale, the energies are comparable so the energies of molecules or nanostructures, they can be comparable to atomic energies. And therefore, this quantum physics view is much more applicable and important to the nanoscale than it is at larger scale.